So here we go with some more examples when we have denominators that are not alike, that have variables in them. And on this page, our variables are going to be, for the most part of a binomial. So in looking at the denominators here, x minus 2 and x plus 3, you can think of these as independent terms. And in order to get a common denominator, you have to have both this term and this term in it. So just like any other common denominator, this has to be able to divide into our common denominator. And this has to be able to divide into our common denominator. So in order to do that, these two together are going to make up our common denominator. X minus 2 times x plus 3. X minus 2 times x plus 3. So if this is our common denominator and we want to get from here to here, we've already got the x minus 2 piece. What's missing is the multiplier x plus 3. So that's what we're going to multiply our numerator by, as well as our denominator, to get the common denominator. And it's the opposite on this guy. He's got the x plus 3, but he doesn't have the x minus 2. So that will be the multiplier that we need in the numerator. So now we do have the ability to use a single fraction bar with one common denominator. And we need to distribute and then collect like terms. So x squared plus 3x plus x squared minus 2x. So the numerator is not collected yet. We've got 2x squared, two of those, and a plus 3x minus 2x. 3 take 2 away. That leaves you with 1x all over the common denominator. And we've got another step to be able to factor out this leading x here. So if we do that, we get x, and then we have 2x plus 1 all over the same common denominator. Now you'll notice that nothing cancels out from here to here. So it's acceptable to leave this as the answer, or you can rewrite it, and this answer is equally acceptable. I think it's always a good idea to go ahead and take out GCFs, because most of the time in a lot of these problems, that's where you will get your term that cancels numerator to denominator. All right, let's do B. So we're looking for a common denominator between these two individual terms. They're different. So our LCM is going to be C plus 3 times C plus 2. And we're going to need that in both terms. Ask yourself, how can I get from here to here? What's missing? I've got the C plus 3. I need the C plus 2. So that's what I have to multiply the 5 by. This has the C plus 2. I need to multiply the 3 times the C plus 3. Don't forget to spread your work out and keep an eye on this minus sign. This is going to distribute. This 3 is actually going to be negative 3, distributing both to the C and the positive 3 when we get around to it. Single fraction bar. First fraction, 5C plus 10. Second fraction, minus 3 times C is minus 3C, and minus 3 times positive 3 is minus 9. Clean up your numerator, 2C plus 1. And again, this one doesn't have anything more to do to write it simpler. 2C plus 1, there is no factor down here. There's C plus 2 and C plus 3. Nothing will cancel, so this is going to be our boxed up final answer. All right, 2 more. We get complicated. That's okay, it's fun. So be sure to factor first. Factor first. Your denominators need factoring. D minus 1, take out the common 4, and you get D plus 3. d minus 2, take out the common 5, and oh yeah, again, you get d plus 3. So our common denominator has 4 and 5 both have to go into it, so that would be 20. And d plus 3 has to go into it. So d plus 3 is going to be part of our common denominator, but we only need one d plus 3. So our common denominator is going to be 20 d plus 3 and 20 d plus 3 over here. How can I get there? How can I multiply 4d plus 3 and get to 20d plus 3? Multiply times 5. How can I get from 5d plus 3 to 20? Multiply by 4. Single fraction bar. Distribute. Distribute this negative 4. So that becomes negative 4d plus 8. Clean it up. Clean the numerator up. 5 d's, take 4 away. That leaves you with 1 d. That's a d. Minus 5 plus 3 is, minus 5 plus 8 is 3. So, look at here. These d plus 3's cancel. Your ghostly 1 is in the numerator, and that's your answer. One more on this page. So, LCD, we need the k plus 3, and we need a single k. This single k, you cannot say that this single k right here is part of this k right here. This plus 3 is attached to this k. You can't split him out. So your lowest common denominator is going to be k times k plus 3. So, do not want this problem to encroach on my space. So how can I get from here to here? Multiply it by a single k. So that's going to give me k squared in the numerator. This second fraction, he has the k piece of it, but he doesn't have the k plus 3. So we've got k minus 4 that already exists, and we have to multiply him by k plus 3. I see some double distribution, all with this negative sign out in front. Egads. All right, let's see what we got. So we have a common denominator. That's easy. We've got this k squared. And now I'm going to do this double distribution, and I'm not going to worry about this negative sign until I get this double distribution done. So that's going to be k squared plus 3k minus 4k minus 12. And now every single one of these signs is going to change when I distribute this negative 1. So I have k squared minus k squared minus 3k plus 4k plus 12, all over, still over the common denominator. Whoops. And now when I clean this up, those are going to go away. I've got a minus 3k and a positive 4k. That's a positive 1k plus 12 over k times k plus 3. There's no common factors. We can't cancel this k with this k because these are not factors. They are added. So this is our final answer. And that's the end of this video. One more to come, I think.